The next presentation will be TRIZ and innovation using big data analysis by Mr. Shree Phadnis, Chairman TRIZ Asia. A little bit about him. I mean, almost everybody knows him, although I will have to read it out. He's the chairman of TRIZ Association of Asia and a level 3 practitioner. He's been involved in consulting and training interventions in innovation, balanced scorecard development, process improvement, quality domains. Shree has been involved in many project interventions like Crompton, Mahindra and Mahindra Tractor Division, Hitachi, Forbes Marshall, Ministry of Defense for Singapore, and many others, which has helped these organizations develop new products which have even won national awards as the most innovative products in their respective categories. Shree is a BE Mechanical post-graduation in Quality Management from Worldwide Quality Management Network, PG in Patent Law by NALSAR. Shree is a certified I3's Directed Evolution Specialist by Ideation. Shree is a certified TRIZ user and trainer and the first level 3 in India back in 2007. Shree is a gold certificate holder at level 3 from Institute of Innovative Design, certified Six Sigma Master Black Belt, educated on effective education and problem management tools based on TRIZ under TRIZ Master Nikolai Komenko, educated on teaching TRIZ to children from the age of 3 to 10, TRIZ expert by Tatiana Sudrok, Alan Nesterenko, my personal teacher since childhood. I give you Mr. Shree Phadnis.
Thank you, Nikhil. And at first, I would like to say that this presentation that I'm going to make over here is not mine. So it's actually a presentation by, as you see over here, a good colleague of ours, Simon D. Wolf. And I'm just presenting it on his behalf because he's been internationally traveling. The presentation structure is, in a way, you might say, like a bit of a trailer associated with those of you who might attend Oleg's presentation tomorrow, associated with how do you do search of information, etc. So this is like a quick precursor. Oleg will obviously get it a bit much more detail into it. Just to give you a quick one associated with the fact that, let's look at, we are all talking about the element that we want to search for information, we want to use big data and so on. So the first question is, what if I were to ask you a very simple question, what is artificial intelligence? And I'm sure if there is someone who is learning something, what is this artificial intelligence? And if you were to go and ask, what would be your thought process? What would be your answer? Pardon? Without involvement of women. Okay, one of the things, most common answer, probably somebody might go and do a Google and see what is there on different websites and so on, right? Let's use artificial intelligence to find something on artificial intelligence itself. So what I'm just trying to depict out here is from a tool which is being developed, and again I have no notions in saying that this is the only tool that you could utilize. There are many tools out there. However, it's just that I have been using this tool, and Simon D. Wolf has utilized some elements of TRIZ background in association with development of this particular tool. We are just connected with it because we understand the logic from where this tool is built. If we do a patent search associated with artificial intelligence using this tool, this is what you will land up with, and look at it. It says neural networks, data mining, fuzzy logic, deep learning, heuristics, knowledge base, machine learning, natural language processing. Again you get some neural networks because obviously the software is just trying to pick up words. So if you make one small spelling change here and there, it would give you that pop-up. So in a way, what you have got is, if you were to take patent database and just apply the simple word, and it immediately helps you to get a cluster of different words which have been associated with this, as a result of which this itself starts helping you developing a quick understanding of what artificial intelligence is. So it's a classic case of using artificial intelligence to decode what artificial intelligence is. And this is exactly what this tool or the methodology which is associated that I am going to talk about is all about. For example now, if I go down patent data driven innovation logic. So the goal over here is the big data I am going to talk about is only focused on utilizing patent data, because today patent data is as huge and as big as it keeps getting. In fact, how many of you keep struggling that when you start searching for data on projects, often we tend to get more lost by trying to study so many patents itself which are there that you tend to give up on patents, and how can we quickly narrow down on patents that we could look at and get some clues on when we start moving forward. Question, who will it benefit? What we are going to talk about is we are going to take each element and just quickly try to get some understanding. It can benefit HR, yes. In fact, patent database till now is often being utilized by IP professionals. Just to give you a nutshell, and I do see a change in the way people are approaching projects, but I have seen a large number of times companies have started on innovation projects, worked all their way till their innovations, and then finally they go to their IP team, guys, can you do a prior art search on this because we want to patent it. And often it has landed up with a problem at that point where they find out that it has already been patented, and maybe the whole journey for that innovation project could have been shortened provided they would have had a prior insight associated with patents along that particular product or technology they were working with, as a result of which number one, not only would it have solved the problem that they landed up with at the end, but an even better benefit could have been that they could have executed the innovation project that they were doing far better and far faster. In other words, a lot of organizations, big organizations especially, they have got IP teams, but the biggest problem with most of the IP teams are they are unfortunately not utilized at the beginning of the project start, but they are often tend to utilize only towards the end of the project. And this by itself does not seem right, because if you are trying to work on something, when you are trying to work with elements, why would you not want to know what is being happening on things which are there. But the problem is not so easy. The problem is, even if I want to search for a patent, for example, if let us take I am working on this pointer which is there and developing a new pointer, what will we search for in the pointer? What are the key words will we choose? Yeah, and very commonly laser pointer and so on, words which are there, and this is exactly where we say that knowledge of TRIZ helps me, where instead of searching I said what do you fundamentally do, you only inform something else, and it is that which changes. So we might want to search from what informs what and means of information, and then let me start searching for my data. What happens as a result of which is I am no longer caught only in a domain associated with some pointers, but I have a much larger piece associated with many things that can help me to get an understanding of it. However, there is a problem also now, because now the problem is the list can probably be a bit more larger, and this is exactly where artificial intelligence can help us. So what we are going to look at is, let us look at it, for example, questions like how can I find new staff and boost their active knowledge, or where do I recruit the best staff from, or with the staff and the skill sets that I have defined, where is it that which skill sets, which staff and which companies are likely to have? Yeah, are these common problems HR might have? Yes. How would you do that? Look at it very simple. If there is a patent which is filed, it not only contains information about the technology, it also contains information based on the classifications of the patent, which industry, which domain, you get information of competition, and more importantly, remember, as I said, if my search is smarter, then I am getting about that smart search information not only with my competitor, but associated with a function which might probably be better. So it might help me with respect to this part itself. Or for that matter, if I go down, how to lock a rental bike. Now look at it, lock a rental bike. So rather than that, it is nothing but a function of hold, right. So if I start creating some search strings which start quickly narrowing down and use artificial intelligence for the same, it gives me no time. Oh, you can see over here there are adhesives, electromagnetic, electromechanical fasteners, glue, hooks. It reduces my research time drastically in helping me to go forward. So if you start thinking, the concept is very simple. The patent database searches associated with the semantic search engines can help me to get these insights up front when before even I am trying to work on the project which is there. Or for that matter, this is just a list. Then if you study something, you can go in details what is there, because please note, even a semantic search engine can get fooled for the simple reason if somebody has used the word electromagnet somewhere, but maybe that electromagnet has got no meaning inside the patent. So you might have to do some amount of screening to go inside, but there will be at least some amount of reduction of research area that we go forward with. Or for that matter, how to measure or detect a magnetic field. Now it is very interestingly, those of you who have been working with TRIZ at level 3 and so on, we have a physical database of effects that is exactly built on a similar logic, where the scientific database has been built. For example, one of the creators associated with some of these scientific database, we have two of them here. In fact, we have Alex, we have Valerie, when they worked with a tool originally built on Tech Optimizer, and I believe Simon was also a part of that team. And all they did was, I think they were the first ones who classified 8,000 odd physical effects with different structures. Of course, I do not know whether how they did it using semantic search engines, or whether they really went the hard way of scrutinizing, studying and compiling, but I am assuming they would have gone the scrutinizing way, because maybe semantic search engines probably did not exist in late 1980s and early 1990s. However, now if you go down, this is how it typically can help, and not only that, look at it, the big data now can not only give that information. For example, you see over here Hall effect, and do you see over here, if I put on this axis the years, it also tells me how frequently, the smaller the dot, it means lesser number of frequencies of usage of Hall effect were utilized in that period, and as time went by, you could see a lot of people have started utilizing it. Now when I look at it in this fashion, which is the one which is relatively less used, if you start seeing over here, there might be some of them which are over here. For example, see this one, and it is magneto-resistance effect, and you can see the number of dots over here look the same all the time, in between too many gaps. Maybe this effect has got a specific application area, but it also indicates it seems to be less utilized. So the chances that it is not been explored associated with my project might be higher, and I might get some insight from here associated with the project we are working with. Going ahead, if I look at it now, how do you solve an oil separation problem in a cosmetic cream? So now it looks like a completely different one, but maybe if you go and do search over here, the search came that this problem was actually faced in peanut butter manufacturing, and the technology from peanut butter manufacturing was straight away adapted over here, as a result of which the problem was solved. Going ahead, what should I design the new projector? What is important? While we have concepts associated with main parameter of value. So how do we define these main parameters of value? How do we get them? Well, we talked about it. I believe some of you would have been even from tutorials yesterday when Alex talked about it. We use voice of the product. We also have voice of the customer, but there is also this patent database, which also starts giving us indicators associated with what could possibly be the voices on which others have been working on. And this, what you see over here, is nothing but fundamentally, as Alex said, it is all about delivering functionality, right, and delivering it at no cost. So if you look at it, if you break it down, performance has to go up, harm has to go down, something to do with interface and something to do with cost. So if you now to go down how to design a projector, this tells me in a quick snapshot, oh, so far a lot of people have worked on performance accuracy, on distance, on illuminance and projected image, and resolution looks to be the largest areas where people have been working on. What are the problems or harm that they have been working on? So if you notice, it is heat, it is noise. If you look at it with respect to cost, it might be cost efficiency, and here you can see it is probably power consumption. Now when you start working on the project, you might later on realize, you know what, in order to get this performance of the illuminance which is there, we needed a much brighter light source. This brighter light source fundamentally resulted in your heat, which has now gone and resulted in the noise, because you now need a fan to cool that down which is there. As a result of that, the power consumption has also gone up, the cost efficiency has also gone up. And this is exactly when Alex talked about it, the cause and effect chains, etc. in the project will help us to understand what is happening, and would help us to then utilize TRIZ effectively to go forward. Similarly, if you were to go down and say, what is it that people have been trying to increase, decrease, change or stabilize? Where does this word come from? This fundamentally comes from the simple concept that in TRIZ we say a function exists primarily when we are changing or maintaining a parameter of the recipient a product which is there. So there is a function carrier and a function recipient. So fundamentally if we are talking about change and maintaining a parameter, that change or maintain a parameter is nothing but change or stabilize. What you see increase, decrease is a change, because it is a further classification of change which can either go up or go down. So in a way it tells me these are all the functions or related to the functions, things that people have been working on. So it is like a quick sharp search that helps me to get this information. At the same time, where could I find out of my domain expertise to challenge? So now when we look at things, you could go down. Now with each one, the semantic search engines today are capable enough to go deep enough in different domains to see how people from different domains have addressed a similar scenario. Or it could be who else is solving similar problems in other domains. For example, you have narrowed down, you know that particular parameter, the patent database can help you to see that domain, you can see that competitor, what type of problems have they been working on, who are the ones, where do we borrow information from. So in other words, for function oriented search also, these kind of search engines play a big role in helping narrow down and quickly locate where do we narrow down our research to. So now just an example of things out here, you could look at, let us take brushing teeth, toothbrush and cleaning teeth. Function state was clean solid, problems related was with bacteria, handheld and slippage. This bacteria goes into surgical instruments, into antimicrobial, into this gets into a different domain which is brushes, jets, mechanical friction, electrolysis, cavitation and so on. The CPC code takes me into different directions of construction. This can get into golf, club grip. Now who would ever imagine a connection between this and so on. So what happens is, it helps us to get into these domains, navigate through these domains, understand where we could look at things, rather than researching a lot of information, narrow down our research area that can make our journey more effective. This is another element, how do you complete my key filter words, and this is where artificial intelligence play a role. At the moment I put a filter word out here, can you also recommend me all similarities of similar words which are there, by virtue of which my search string can be made better, as a result of which I can go and search things better. So it is another very simple application of artificial intelligence that has been utilized within the search domains. Or how can I predict property variations in my product or technology? So for example, this what you see out here is nothing but one of the dynamization trends that is visible over here, where if something is completely rigid, with over time it might get a single hinge, multiple hinges, might get completely flexible and so on, and finally might move to a field. So what you see out here is this advantage of having this search over here helps you. Now if this is where this piano was, this is what it could become to it, so what next? So the answer is very simple. I don't have to break my head over it now. The answer becomes it could be something like a projected keyboard which we can now utilize. Keyboard exists, so even the piano could theoretically exist. Now comes the next part of it is, let us understand. It is critical to know the fact that when I defined a function, I said what is the function? Function changes or maintains some property of the recipient. In other words, what is a universal solution to any problem? There is only one solution for any problem in this world. It is something, a value of some property has to meet a particular criteria that you have defined, is a universal statement for any problem. The challenge is what should that value be, what should that property be that I can insert, that is all it is all about. So in a way, when I start looking at it and I look at functions and I look at porosity and I say, see, to contain I have got porosity this way, to stabilize I have got shape this way, to hold it is this way and so on. So in a way now what you are getting out here is these are adjectives. In a way, adjectives could be considered similar to solution directions. So in a way what you now get is, if I am able to search with functions, with nouns and adjectives, I could also get some hints, some clues about areas associated with solutions. For example, you can see here hollow to absorb, hollow to adjust, hollow to carry, hollow to circulate, hollow to contain, hollow to enclose and so on. So it is a very simple way by virtue of which adjectives with functions can typically get utilized. Similarly, if you look at it now, what is the difference between science, between technology and between market, and how do you connect them? Is it not all about that? So the answer is very simple when you look at it. Science, notice over here, automation, color, flexibility, geometry, information, what is all these? Different adjectives, right, which are nothing but properties. What is technology? Is nothing but verbs, which is nothing but representative of functions. How do you connect it to market? It is with nouns, because nouns are fundamentally objects which are there, so we could make these connections which are there. So in a way, having this logic with adjectives, verbs, nouns helps us to navigate through the databases more effectively and get certain insights associated with our project that we are working with. What are the properties of features, what are the functions or benefits? So this is again a common one. So for example, I go forward and I say we have electric toothbrush, disposable toothbrush. See now, it is a connection that is made with the adjective with the market. And then you could look at it in terms of flexibility, what has happened, what has flexibility enabled you to do. So enabled me to do better cleaning, enabled me to get better grip. Again some example, see porosity, to rinse, to contain, to store, segmentation, to rinse, to replace and so on and so forth. It just goes further in trying to detail it down, I am not getting into each one. Now comes this, who are my prospects, who are my competitors of my client for a specific product, because this is often the question that I have a product but how do I discover my area where I could go. So it is very interesting, and in TRIZ we do have a methodology which is associated with what we call as reverse function oriented search, where it is a very algorithmic method by virtue of which we really decode which functions are you really doing excellently well. Then we try and revert backwards to find out which industries have a need for that particular function, and as a result of which can we adapt our technology effectively to meet that particular requirement. But this can be enabled from here also, because once we have that part, this search is done, it is easier to search for those potential customers or segments of markets wherein we could apply this methodology. Which other packaging market has SiOX barrier coating? Common question again. Again answers, you can see quick answers it starts giving me in domains which are there, which is there. I could obviously, please note again, they are just indicators. You still have to do some work of going a bit deeper and trying to read those patents, get some understanding, create some indexations of it and so on. This is just nothing but on the website you have got an help which indicates how you could navigate through and so on. But what is the whole logic then? It starts with very interestingly, and this is, as I said, this is Simon D. Wolf's interpretation of TRIZ and application with respect to TRIZ, but from a patent database application side of it. So what he is looking at it is, what value do you want, in other words, if you notice since morning we were talking about MPV, the only difference is he does not call it MPV, but it is, if you know you are putting an MPV over there, it is fine. What is it that you want to make good, want to make easier to use, want to make less bad, want to make less cost, is nothing but your aim. So your first goal can be this, which is IP driven innovation, can start from here. Next part of it is, if you heard it since morning, a lot of times this word resource has been utilized, because in TRIZ we do believe firmly that it is all about smart utilization of resources which are there. So what we look at resources, this is nothing but it is an interpretation put over here of a methodology in TRIZ or a model in TRIZ called multi-screen thinking, or sometimes people call it 9 windows, though I do not like the word 9 windows because it is not 9, it is actually multi-screen. So it is nothing but anything which exists. If you were to consider a box, right, the box comprises of sub level components, but the box also exists in a super system. So if you notice, Alex used it, Valerie used it, the word super system was used many times. Super system is nothing but its higher hierarchy. But what is important is, it is not only searching here, but it is searching before in time. So for example, if I, it is a very interesting thing, I will give you, and I use it in training programs a lot, it is the easiest. If I use the word tree, right, how many of your mental picture right now is a tree? If I were to ask, how many of you are thinking of only one tree, or you are thinking a bundle of many trees like a forest? The chances are you are all thinking of one tree. You know why? Because I said tree. The likelihood that you are considering a forest is not there, but eventually does a tree exist by itself? Does it not exist with probably forest around it, or many other trees, or maybe in Pune maybe the tree might have some roads besides it. But the point is that this is exactly where we say that when we look at systems, systems tend to be looked only from the small view which is there, but when you look at it from a super system it could be different. How many of you will think with the tree that the tree could have been a seed some years back, or a small sapling that probably some government official came and planted, or maybe some big minister came and planted, you never know, or you planted. But would it come to your mind that it was just a small sapling, and when it was a sapling, what was around it could have been different, the resources around it could be different? Or would it ever occur to you that the tree is tomorrow going to be your table? In future, the same tree now gets cut into boards, gets cut into this, it comes like a table to you. Would it occur to us naturally to search in these domains? The chances are no. So this is exactly where we say, where what resources we have unboxed, it is like use multi-screen thinking to try to look at resources which are there. Now can you abstract your system using properties and functions? TRIZ is fundamentally, let us understand, and I look at it this way, it is not only TRIZ, it is a very simple statement, everything that we know in this world is only a model. Now what did I state? Please understand, the reality is what this is. When I say it is a table, the table word also is a model, you created it. If I would have given a name since childhood at pineapple, you would have called it pineapple. If a child when he was shown in the beginning, when he was born, he would have been shown an apple and been told that this is watermelon. All throughout his life he would have believed it to be a apple. Apple is equal to watermelon. When it comes, he will say it is apple. It is a model. Unfortunately, what happens is this model thinking is utilized everywhere when we work with. When you work with mathematics, everything is model. When you are working with simulations, we have to make a mathematical model, we need an equation, for that we need data. When you use language, language is a model. So what we typically say, everything we know of is actually a model, and TRIZ is a process by virtue of which we learn to convert things into multiple models. So, for example, when Alex said function model, it is a model representation of the problem. Cause and effect chain model. The models helps us to go through the current paradigm to a different paradigm for us to think and look at what happens with the model, and from that model then we just abstract ourselves to look at what are the solutions to that model, and then we just adapt those solutions eventually into our work area. That is how the whole principle of TRIZ works. Once you have got that particular part done, then comes this, what properties can we change, because now if I come to know what properties are there, what we can change, next question is what value will we derive if we change something, as a result of which this can become our complete template associated with just using IP for the role of trying to innovate. This is just a sample example of something which is just filled in over here. Now, how can I research, visualize and share quick results, because this comes, the next part of it is, because when you are working on a project, it is not about you alone, you are working in a team. So, you need to have abilities by virtue of which you are able to do the search, you are able to research and you are able to share it quickly, and this is just nothing but how you can share this information quickly. And then comes the next part of it is, yes, it is all about applicability to everywhere, and as I said, this was typically a complete presentation of Simon de Wolf. I was just playing the person of trying to I will say, you know what, impersonate him and stand over here. I do not know whether I did a good job or not. However, the way which we are trying to put forward is that when you are looking at big data, there is enough big data which is available in patent databases. Often there is a case, and I will tell you, this is one thing which I have been struggling with so many people, that, and especially with IP professionals, because what happens is, a lot of times IP professionals would want to get a lot more into, you know, give me specific patent data, and we often say that, you know, in the initial stages of my project I might not be interested about having very specific answers, but I want to have a generic direction. So, it is something like this: if in this room I were to tell you that there is a location where there is gold, right, would you start digging everywhere, or would you try to create some approximation methods by virtue of which you try to approximate where likely are you going to strike gold? Once you have done that approximation of where likely you are going to strike gold, now when you start digging in that particular area for that gold, the chances that we will hit it is better and faster with lesser effort. That is exactly what we could achieve with the big data. So, now thank you, thanks a lot, and what questions do you have? And I will try to answer it from Simon de Wolf's perspective. Yes.
There were many interesting things in presentation, but out of that, many things we are already doing with manual intelligence.
Yes.
So, most of IP people are doing it.
Exactly.
And where then I am interested to know where artificial intelligence is helping, because word crowd or alternate terms and all these things, they come from thesaurus readily.
True.
So, where it's, what is the benefit of professionals with this, and where artificial intelligence plays?
The only thing is, the IP professional who is able to do all this, how many years of experience does he have? And how many years will it take to give you a quality output?
At least 10 years will be required to get it.
If I were to hire somebody from engineering college, train him for 1 month, and will you start giving me outputs in the second month? Main difference. Remember, a lot of times the whole goal, why, this is a very common one that you will be looking at, why is artificial intelligence threatening? The whole reason for the threatening is it enables power to do things to people who are much lesser skilled than what was required earlier.
Yep. Probably extension to your answer, probably it is threatening freshers. How is it threatening the experienced people, or basically how it is going to add value to them?
Exactly. See, what happens is very interestingly, number one is this. Number two, I'll give you a very live example. It so happened in one project, the IP person spent time, but the time taken for him was 1 month. Now, if the person is given a duration that the project duration is 12 weeks, if he is going to take 1 month in only getting this input first, after which his project starts, how long do you think the overall project duration is going to take? The question today is, what is happening is that the need for crashing project duration times is also drastically coming forward. So, if you look at it, it is not only about the output which is there, it is also about the time, because manually it is of course the best, for the simple reason you are going through it, scrutinizing, getting, reading, but the biggest advantage, again the disadvantage is time it takes for doing that can sometimes be humongous. So, if you look at it, all what big data crunching, number crunching is helping us with AI is getting it faster. Probably it can be achieved with lesser skill sets that people would have been needed to do it. Of course, with time going by, maybe the lesser skill set person might also start getting more skill sets automatically. So, he would obviously start getting even better at utilizing it.
With this device, suppose one company wants to see, they have already a patent, and they want to check how many people are referring that patent and there is a possible infringement happening. Will it be used for other purposes?
Okay, what it can only help you to do is, see, look at it, you wouldn't know how many of them are referring to it, because referring is not known, but if somebody is utilizing it eventually for filing some patent somewhere, if you are going with your function and you are able to see other functions which are there, and if you are seeing in that functionality which are those competitors or the domains which are implementing it, you can definitely get some insights that there looks to be an opportunity that they are infringing us. Yes, that it would help you to narrow down which is there, but as very rightly said, an IP professional exactly does this. What he does is he will take this information, he will start putting into the classification, look at that particular function, but the only thing he will miss out, because he cannot do it at a function level, he will often take it within a domain level only. So, he will only restrict himself with the boundary of a domain, but the biggest thing is that often the highest amount of plagiarism, that is why the doctrine of equivalence exists, is primarily for the reason that same function, but the function can be so remotely at some location that we might not even search for it, and it might even be granted a patent, so we wouldn't even know about it. Yeah.
So what exactly is the difference between the software Goldfire and this process, or the patent data driven innovation?
Okay, those of you who have the software Goldfire, just to give a background, Goldfire is the next generation of the version tech optimizer which I just talked about, where Valerie, Simon, Alex were all a part of development. Goldfire just added the patent semantic search engines based on this part, and they developed it further to work over there. The only drawback with the Goldfire is that later on, I believe it got sold through multiple iterations, and the cost of it has become so prohibitive that most of us, we no longer even think or recommend about it, which is there. If the company can afford it, well and good, because I believe it's really very expensive. It goes almost, any idea Valerie, how much the Goldfire costs?
Now?
Yeah, currently?
Well, currently that's changed because invention machine was sold to IHS markets, and I think before that the price was something like 20,000 euros per license, and then you had to buy it in combination with training for 10,000, so total cost would be 30,000 per license. But basically then they moved to selling corporate licenses, and right now I don't know what's
It's really very expensive, that's what I've heard.
Oh yeah, that's definitely, you need to pay a lot.
Software was tested because this software, it can identify functions, right? Text, and they process this text using this software.
Okay.
And you know, instead of this very kind of it's drama, it's strategy, it's romantic, right? It just removed all this romantic stuff, and instead of this drama, it was like a police report. Like, you know, Romeo loves Juliet. You know, this Tybalt kills Mercutio. Just only functions, very short, but all kind of content of this drama was squeezed to just a few functions.
Yes.
Very interesting.
So the fundamental difference was nothing but as I said, the idea for this came from the TRIZ part of it, of course, with some modifications, etc. that Simon D. did put in place. Yes.
I have a question here. What Nilesh has mentioned that some of the stuff which has been shown here is all conceptual. So as you mentioned about that, this
tool is making use of big data to arrive at these problems, and you mentioned various stakeholders in the company, starting from a marketing function to the HR function. So some of the way these slides have been shown, there's a problem statement and there's a clear-cut visualized output
Yes.
of it. So I would like to understand from your experience, your relationship with how much is involved. So is it like possible just click of a button everything, or is
Yes.
it manually? How much is the manual intervention versus plus artificial
It is
part?
pretty much automated. A lot of information, it comes quickly. For example, at your latest a project that I was just working on was in an oil and gas industry, where the problem was associated with can you imagine jellyfish getting into a seawater intake system and jamming a whole complete seawater intake system, as a result of which a gas manufacturing plant being out of commissioning for 4 days, billions of dollars loss. In one day, I was narrowed it down to 40 patents. I precisely knew what technologies the countries were facing, and any guesses which country had the highest number of patents on. And it wasn't, I anticipated it, but for me it turned out to be immediate. It turned out to be Japan. Japan, because of the reason that in Japan, there is the sea waters there have got jellyfishes which can be as large as human beings. And which country has nuclear plants, and they also utilize sea water as the primary source, because purifying that sea water and or rather doing an RO and utilizing it all is just out of the question, because the amount of water needed is sometimes massive and huge. So obviously it made a lot of sense that what is it that they did, but when we studied it, quickly said, and it gave us a quick directions in terms of what it did. Question is, could it be done with a person who has a patent knowledge of search? Yes. The only thing is how long he might have probably taken could have been much longer than the time taken by us. That's the biggest advantage, as I said. Artificial intelligence just helps us with that part, but of course it comes with a drawback. There is a contradiction problem here, because when artificial intelligence does the search, it is working with the word which is put over there. Unfortunately, it's only when you read a patent you start sometimes realizing that word probably was not the right word to be utilized there. Whereas when you do it like a manual search, you are obviously more precise, because you are already narrowing down the patents and reading the patents and indexing it. So yes, that's the advantage. So as I said, it's a good tool by virtue of which you could narrow down, but would it be a very good tool for prior art search? It depends. Now you will have to use it accordingly from that, but it was never made from a perspective of a prior art search. It was more made for a perspective as an aid for an innovator. Yes. We can have the questions later. Okay. There's just one last question.
Yeah.
Yeah.
This is a bit important one, because from what I learned, I just remembered now when I studied patents like 10 years back, that the most difficult test for clearing a patent is the rule of obviousness.
Yes.
So we are using AI for patent search to find relevant solutions, but the guy in the US patent law office or the Indian patent law office, he'll also use another AI to find out that is this solution really obvious or not.
Yes.
So that could be.
See, this obvious part is very interesting. When you go details, it basically says the law says it is about obviousness as written to the person skilled at the particular art. So it is always subject to many things, the way you drafted the word. But if you notice, it is not what I am trying to put forward. It's not about the wording. What we are saying is there are already granted patents which are there. It's a way to just get an indication so that we can narrow down our research areas when we are working with our innovation projects. That's all. And yes, if you are able to do that upfront with patent experts, yes, the only drawback with that is they might take much longer time, which is there, whereas often people could crash these lead times because you don't want absolute precise solution, but you want generic directions of what has been working, what are trends, what has been utilized quickly to move forward on your project.